I really like this website for practicing using equations. So we're going to use the buoyant force equation. This website's called the Physics Aviary, and the specific simulation that we're not going to access, but we're going to use is called density of rock determination. In this problem, you will have to determine the density of a rock based on the change in a force reading that occurs when the rock is lowered into a fluid. When you're ready to start the problem, click on the begin button. So I'm going to click on the begin button. I just took pictures. And you'll notice that what they've done is they've given me the tension in the string holding this rock is 10.8 newtons. And it says record your tension when the rock is suspended in air, and then click on the rock to lower it into the fluid. So I know it's 10.8 newtons. Write that down. Another thing I'd point out to you is down here, kind of in small print, it tells you the fluid density is 814 kilograms per cubic meter, which is less dense than water. And it tells me the gravitational field strength is 6.2 newtons per kilogram, which is less than the gravitational field strength of Earth. So I'm going to dip that rock into this liquid. And you notice that originally it had a tension of 10.8 newtons. So now the tension is 6.9 newtons. Well, what's the free body diagram look like for this object? Well, I got the gravitational force down, which I know is 10.8 newtons. And I've got a tension force up, and I also have a buoyant force up. Well, if my new tension force is 6.9 newtons, that means that the difference between 10.8 and 6.9 is my buoyant force, which in this case is 3.9 newtons. So what they're going to do is ask us to figure out the density of that rock. And the way that they can do that is to figure out the mass of the rock and the volume of the rock. I can figure out the mass of the rock pretty easy. The mass of the rock is the weight of the rock is equal to the mass of the rock times gravitational field strength. I know that the weight of the rock, we've already figured that out before, was 10.8 newtons. And I know that the gravitational field strength is 6.2 newtons per kilogram. And when I use that information, I get the mass of the rock to be 1.74 kilograms. I'll plug in my numbers. I can figure out the volume of the water displaced, which is the volume of the rock, by using my buoyant force equation, which is rho Vg. And I'm interested in figuring out V. So my V is my buoyant force divided by rho G. And I'm going to use the rho of the fluid, the gravitational field strength of 6.2. And then remember, we figured out the buoyant force in the previous slide to be 3.9 newtons. When I do that math, I get the volume of the fluid displaced, which is equal to the volume of the rock, is 7.73 times 10 to the negative fourth cubic meters. So finally, if I want to figure out the density of the rock, I take the mass of the rock divided by the volume of the fluid displaced, which if the rock is completely submerged is the volume of the rock. And I take this number divided by this number, and I get a density of 2,251-ish kilograms per cubic meters, which you notice is more than the density of the fluid. That's going to be important because next video we're going to talk about how much something is submerged and how it depends on the density of the object and the fluid. So what should we take away from this?